Okay. Past year question chapter 5, question 25a part 1. Where in these questions here, we would like to find out what is the domain for function gx, where the function gx is something like extraordinary compared to what we have learned all this while, where you find out that this is actually as if like the combination of square root function and quadratic function with the operations of divide with each other. What we usually do in our function is that we just have one single function like just a square root function itself or just quadratic function itself. But now when the time comes to the combinations, how can we happen to get the domain here? So before we come to the solution for these questions here, let us have some extra ideas. Well, it happens to help us to find out the domain and range by algebraic methods in the future. So let's say now I consider the incident that let's say I have function of gx. This happens to be the case equals to the sum of two functions, let's say rx and also sx. Then what will happen to be the domain for the function g here? So for your info, the domain for the function g here will just equals to the domain for function r intersect with the domain of function s. Similarly, when the time I have the function g is equals to function r and function s, they have the relationship, the operation of subtract. So the domain will still refer to the case of I happen to have the domain r and s intersect. And what if I have the operations of multiply, rx multiply with sx? So the domain for g is still referring to the case of domain of r and domain of s, they intersect. And the last one is the one that we want to refer to solve our question. When the time I have my function of g now is happen to be referring to the case of the two functions, they divide each other. Then how to get the domain? So the way to get the domain, it will similar like the one on top, but with one more extra condition, which is domain of R intersect with domain with S, and then intersect with one more extra condition where my denominator functions shall not equal to 0. If not, the function for gx is happen to be undefined. So this is the idea we need to use to solve for this question, A part 1 here. And therefore, have a quick look. So I will treat the function on top here. This is happen to be the function of rx. The bottom quadratic will be sx. And therefore, I come with the assumption I let rx and also sx as follow. So the domain for r, it will be -1 to infinity. By right, you should able to determine quick enough for the case of square root function, where the idea for the domain is just as simple as you take the content inside of the square root, you have it, the case of greater equal to 0. And you solve these inequalities, you will get the domain. For the case of quadratic, if there's no specific requirement, by right, in general, it should be infinity to infinity. So as we happen to say just now, the conditions to find out the function of g, if let's say I happens to have my function of g is in the form of rx over sx. Therefore, the informations I need for the domain for g will be domain of r intersect with domain of s, and also intersect with the condition my sx is not equals to 0. So therefore, I already have the information of domain of R and domain of S. I need one more info, which is what is the interval of X such that my Sx is not equal to 0. So therefore, for the case of the Sx, which is x squared minus 4 not equal to 0, we find out that my x can be anything but not positive or negative 2. And therefore now, we apply this to get the answer for the domain. So we have 1, 2, 3 interval to consider. And then let us intersect all three of them and get the answer. By right, you can just use one single number line to intersect all these three intervals, where the first one, -1, include -1, and then greater. The second one, infinity to infinity. That means I have arrow towards both ends. Every single point between the two arrows is happen to be connected. The other one, the last one, anything but not plus and minus 2. So let's say here is -2, here is +2. So anything but not both of them, that means I will have similar like the case of infinity to infinity, but left two whole there, or -2 and 2. And what I want for this case here is I want the intersection of all these three number line. And I find out that for sure, the part that I highlighted in green, all three of the line, I happen to have this, I have the common value, I have intersections. This part also. But how about the borderline value -1 and 2? Then we need to further investigate. So we find out that for the borderline of -1, all of them have the value of -1, so this is included. But for 2, you find out that one of them doesn't include, so I must exclude the 2, and therefore I can have the answer as this form here, where I start to include -1 until 2, but not include 2 because there's a gap there, and then from 2 to infinity. So this is how I get the answer for the part A, for question part A, first part.